Well, good day, everyone. In some cases, days. It's necessary to have a laboratory with the necessary equipment, highly qualified personnel. And due to the use of chemical reagents, usually there is environment pollution. Another approach is the online analysis with methods based on atomic and nuclear physics, such as radiometry, neutron activation analysis, gamma activation analysis, or X-ray fluorescence. The benefits of this online analysis is that they do not require any pre-preparation of the sample. They exclude human factor in the random errors. The results are obtained practically in real time, and it allows automation of the analytical process and facilitates the quality control of the production. And of course, they do not produce chemical pollution of the environment. In this case, the proposal is X-ray fluorescence analysis, and this is one of the depiction of the process. So we have the conveyor belt with the material. We install a special suspension for the analyzer. Inside the analyzer, the X-ray tube emits X-rays, and the material emits fluorescence that goes into the detector, into the spectrometer and the multi-channel analyzer. Then all this information goes to the computer where it is shown the results. So we define a measurement time for each analysis. So let's say 3 minutes. So once the conveyor belt starts moving and the analyzer starts to the measurements, every 3 minutes we obtain a result, but the analyzer is constantly emitting and detecting radiation. So we can have, this allows the automation of the analytical process, but also the results and the parameters of the analyzer can be transferred into the general control system. So this is a picture of the analyzer already installed on a conveyor belt. So it is not a laboratory analyzer. It is for industrial purposes. It has been designed to work year-round in harsh conditions. So it is hermetically sealed, so it can operate in dusty environment or humid environments almost in the open air. Inside, the temperature is stable, so it can operate in a range of temperatures from -40 to +50 degrees. And due to the metallic case and the reliable electronics, it is resistant to electromagnetic interference and strong vibrations. There are factors that influence the analysis, like the lump size, the distance between the analyzer and the material, the inhomogeneity of the material, the humidity of the material, and the amount of lighter elements that the detector cannot detect, the analyzer cannot detect, and the dustiness in the air. However, we consider all these elements, all these factors, and we have successfully applied this analyzer for different cases, and now I will show you some of these. This is the chromite lamp for detection of chromium and iron. Here is the analyzer already mounted on the conveyor belt. We can see the lumps, the analyzer, and the suspension system. The conveyor speed is 1 meter per second. The lump size between 15 and 18 centimeters. The distance between the analyzer and the ore is 15 centimeters, and the measurement time is 60 seconds. So every 60 seconds, we obtain a spectrum like this one. We have the elements, the lines of the elements that we are interested in, and some other that are detected, in this case, titanium. So we have the concentration for chromium and iron. The detection limit for each one is 0.07, 0.08, which allow us to have a very good accuracy in the results. So for 300 samples, we have a comparison of the results obtained in the laboratory with the analyzer, and we can see the agreement between the results is good. Another example is the analysis of copper zinc sulfide ore. So you can see the picture of the analyzer and the suspension system is simple. Here are the parameters of the measurement. And again, here, the measurement time is different. It's 300 seconds. So here, every 300 seconds, we obtained a spectrum like this. In this case, we see the elements that are detected. And our interest here is the copper. So we see a small peak of copper there, here. Because the range of concentrations is from 0.05 to 0.8. The detection limit was very low, like 0.008%, and which allowed us to have a very good accuracy also. So here in the picture, you can see also the comparison of the results from the laboratory with the analyzer. This is another example for the analysis of iron cake to determine cobalt. You can see the construction in this case is different. It had some wheels to allow the analyzer to move over the cake, but it has also the suspension to avoid the analyzer to sink into the material and to provide also stability for the measurements. Here are the parameters of the measurement and the spectrum that we obtain. So we have 8 elements here. The element of interest, the peak is overlapping with the peak of one of the peaks of iron. So we had to perform a different analysis, but at the end we obtained for cobalt in a concentration from 0.23 to 0.36%. We had very good results. And again, we can see the comparison with the laboratory, and the agreement between the results is very good. And another analysis with another material is for vanadium slag. Here are you can see the installation and the measurement time again, the parameters, the measurement time 300 seconds. For every 300 seconds, we obtain such a spectrum with the elements that are detected in the slag. So if we zoom in the region of interest, we can see more detail of the spectrum. And we see that the peaks are overlapping with each other. So we had to perform the convolution of the peaks, and we obtained the results of the concentration for each of the elements detected in the slag. Here are the detection limits in parts per million, the sensitivity, and the accuracy of the results. This is another type of analysis. This is for different types of sand, both dry and wet. For quartz sand, nepheline cyanide, and feldspar. Here is the installation over the conveyor belt. And this spectrum here corresponds specifically to feldspar. It shows the peak of argon corresponding to the air between the analyzer and the material. But it also shows the different elements that are detected in the sand. These results here below correspond to glass-grade quartz sand with up to 50% of water content. So the spectrum of quartz sand only shows the peak of argon and the peak of the impurity. The peak of impurity corresponds to iron. So here are the results for different concentrations obtained in the laboratory and compared with the analyzer. And here we can see the results obtained. The agreement is good again. The software allows us to have a visualization of the trends for the operator. So he can have an overview of the performance of the analyzer and the results. So we have, the first column is the number of measurements. Date and time is the second column, and the yellow columns correspond to the elements being analyzed. So we have, in the second row, we have the results for the last measurement and an average for a specified number of points. Usually the operator will not see this screen, but this is just to show that the parameters of the analyzer and the results can be transferred via Modbus protocol to the control system so that the operator can have full control of the analytical process and of the analyzer. So these are just some examples of the application of the analyzer, but the list is large and with different materials and different elements, both light and heavier. So the company, Baltic Scientific Instruments, we are located in Latvia, in the north of Europe, in the Baltic region. So most of our applications and installations are in Europe. But we also have some applications in Africa, in Asia, and in Australia. And each of the applications is installed according to the requirements of the plant. So final remarks, I would like to mention that the use of online XRF analysis is growing among the mining enterprises because it allows to have a solution for non-standard problems due to the variety of materials that it can analyze and the number of elements. The analysis is fast. We obtain results practically in real time, which allows the mines to reduce the cost and the time for the analysis. There is a reduction of errors, and it allows also an automation of the analytical process and incorporation to the control system. It facilitates the control of the quality of the production, and it contributes to have a more environmentally friendly mining industry. So finally, I would like to thank you for your attention. And if you have any questions, you can here or in the stand. Yeah.